and you see it's written over here workspace. This is where all the variables and their type is given. So these are some of the variables which are there, and this is the types. Like for example, this is a variable with the name answer, which is given the which is a complex double type of this dimension. The dimensions are given over here. A square bracket means it is an array. As you know, Matlab stands for Matrix Laboratory. So we work mostly with matrices, and we have got many types of objects. Like we have got audio player, we have got double, we have got complex double, simulation output, and normal integer types also. This is called the editor. This is where we give. This is where we give the code. So I hope everyone is familiar with Python. This is almost similar to Python. We have got an editor over here where we give all the codes, and this is the command window where if you want you can give one command and it will run that only. So say for example, if I want to plot a signal, I can always type over here plot signal, and it's going to plot a signal. Okay, so and this is the fold. This is the environment we are working in. This is, I think, in documents. So this is all the files which are there in documents. Okay, so one of the first things what you do is you need to clear all the rubbish over here. So one of the things which we saw was that figure. How do we close the figure? Either you press that cross or you type clear all. And clear all is for workspace. So clear all. This will clear the entire workspace. So as I press enter, it's showing busy. This, if it is blank, it shows, or blank or ready, it's saying that it's ready for the next command. If it's busy, it is working on it. So now you can see that the workspace is gone, and now this command window, if you have to clear it, you put CLC. Now let's start a new experiment. So this is the plus icon where you can start a new script, or you can go to home and you can either put new script or new live script. We are going to go through both of them and see what's the difference between them. For our experiments and all, if your teachers are a bit kind, they are going to ask you. They won't permit. They will be okay with the printout. So one of the forms of making your life easier is to just put it in a live script, and this is how your live script is going to look like. I'm going to maximize this. So in the starting, you're going to have your heading and all, and then all the graphs and all are going to be shown inline instead of as a separate window. And this thing can be exported as a PDF, and you can take a direct printout of it. Okay, fine. So we take new script, and this is where the new script starts. So first we are going to go through some basics of Matlab. So Matlab only works on digital data. It does not work on analog data. So you can't make continuous signals or continuous functions and all. You always work in digital functions. So in some of this, you can see that this is a generation of signals. Okay, fine. So this is a digital analog sine signal. I have labeled it analog sine signal, and this is called a digital sine signal. Or I hope everyone knows the difference between analog and digital. Yeah, I can't hear anything. So, can anyone just open the mic, make it a bit more lively? There is Krishna. Hello, Krishna. Oh, she has gone.
Yeah.
Yeah. Krishna, ask everyone to unmute the mic so that I can listen to their feedback. Okay, now for
you may unmute your mic.
Okay, everyone who has a doubt or if they have a Matlab software which is running live or parallel, you can always work along with me. Else, you can just listen to it. But I kindly request some of you to unmute your mic. It's like as if I'm speaking in an empty room, which is also true.
Okay, if anyone have any doubts, you may ask him by unmuting the mics.
Okay, so moving on.
And
Now,
Aanchal,
yeah,
could you zoom the window a little bit? I think it's not.
this window.
Yeah, yeah. The
Okay,
text
fine.
are not visible.
Oh, text is not visible. I think that's a problem of your network. Or is everyone viewing on phone? If that's the case, I will increase the text size. Accessibility.
Hello? Yeah, actually, you
Yeah,
don't have
hello.
to do that. You can simply zoom into your screen. I mean, others who want to read, they can simply zoom into their phones.
Okay, okay, fine. Thanks a lot. So if everyone can take their pointer, that's a really good point. Okay, so next, yeah, so analog and digital. Now, how do I show this? Okay, anyone see my paper over here? Hello, Krishna. It's showing recording. I can't see it.
Yeah, we can see your paper, but it's not clear.
Okay, fine. So, okay, fine. So this is enough. Now I can see my paper. So, all the this is a computer software. So all the data is stored in registers or in say bytes. So there's no way we can store an analog signal. So how would an analog signal look like? So uh, this would be an analog signal. Am I correct? So this is the analog signal of a sine. But for a digital signal, we'll be taking the samples for each point over here, here, and here. And at the rate at which we take the sample is called a sampling rate. We'll look for as we run the simulation. I will show you how the wave will be different as you change the sampling rate. If you increase the sampling rate, you see a high resolution wave. And if you decrease the sampling wave, you'll see a low resolution wave. You can't make out whether it's a sine or not. Okay, fine. So so therefore we store each value in a cell, and the sum and the collection of these values is called an array. So that's what you see over here. Oh, God. Okay, fine. So that's what you hear is see in the workspace when we run this program. How do we run this program? We go to live editor and then we run. Okay, so all these array continuous or digital, whatever they are, continuous or discrete, they will be having a single value. So how I simulated how I showed the difference between an analog and a digital value is by reducing the resolution. So over here, can everyone see this workspace? In this workspace, you can see some of them are called XAXD. So let's take the example of sine A and sine DI. So sine A is for sine analog and sine DI is for sine digital. So you can see an analog one I have created a big array. So it is a high resolution array and I have asked it to plot it. So it is joining the dots. So you can see therefore as we go down, this sine looks like a high resolution sine. It looks like a proper sine. It looks as if it is continuous. But if you look at this digital, you see it is broken. That is one of the reason why is because I used the function stem. So this also we'll go through after a short while. What's the difference between stem and plot? Okay, so moving on. So now you know workspace and analog and digital differences in MATLAB. Now we'll go to the next. We'll go to Yeah, one of my best friends in Matlab is called the help and documentation. So that is this search bar over here. So no MATLAB programmer is perfect. It's a huge software with lots of functions. So as we are all students, one thing which we should make a habit is referring to this documentation. So say for example plot. How do I plot a wave? I will just type plot. So I hope everyone can see this. It will show plot 2D line plot. As I click it, it will show the documentation for plot, and I can read it and I can understand it. So this is showing the syntax, and with each syntax it is showing the description also. So this first description is for the first syntax. The second description is for the second syntax. So plot is a way of joining the dots, and stem is a way of just plotting the dots in this way, in this, as you see in this window. We'll all see that later. I was just showing an example of help. If you don't know anything, refer help. Say for example, in this test, this I was doing just yesterday, I didn't know what this audio player was. So I had to search out here, what is an audio player and how do I work with it. Now next, we'll go to the different applications inside MATLAB. So as you want to go into deep learning and artificial intelligence, you don't want to type the code as if it is Python or something, right? So one of the easier ways to do is you use an inbuilt app. So as you select here apps on this ribbon, you can see there are multiple tabs: the home, plot, live editor, insert, and view, and apps. So if you click apps, you can see this. In this, you have got a drop down menu and you can see all the apps which are over here, all the applications. These applications are grouped in something which is called a toolbox. It is called a toolbox. So if you pirate MATLAB, you can get all the toolboxes. This is the official version of MATLAB. I logged into my account over here, if you can see. So the official version of MATLAB from CUSAT does not give all the toolbox. Mm. So there are only certain toolboxes which are there. So these are those toolboxes which come with our CUSAT MATLAB license. So each toolbox have got multiple applications. So if you want to create your own neural network, you can create it. You just need to go to that respective toolbox and you can select that app. This will be somewhere over here. Okay, yeah, deep network designer. So you select this. This is an application, and after you work with this application, it will automatically generate a code for you. And this is a highly graphical application. It does not, it does not bore you like the normal MATLAB script does. Oh, and one more thing. When you are installing MATLAB, try to install it on your M.2 SSD. Don't install it on your physical hard drive, like the magnetic hard drive, because it will load very slowly, as you see over here. So see, this is a deep network designer. You can select any of these networks. If anyone is familiar with deep networks, they'll be able to, they'll be familiar with this. I have worked with Google Net and AlexNet. Rest of them, I have no idea what they do. Like AlexNet, it's already downloaded, and Google Net. So you can select them, and either you can do a transfer learning by changing the layers, or you can create your own network. So this is just one of the examples. If someone is interested in PID tuner, they can work with PID tuner. I have not worked with PID tuners. So this is the application. And now next is Simulink. If you go to MathWorks website, one of the three main products which they show is MATLAB, Simulink, and Polyspace. I think Polyspace is already installed. I have not worked with Polyspace, but Simulink is one thing which is nice if you can work with it. So how do you open Simulink? It's not a separate application. You go to MATLAB, you go to Home, and then over here you can see the tab for Simulink. So over here you can click Simulink and it will start. And I have not clicked it, but over here you can see this is how the Simulink looks like. This is the empty workspace, and this is what they call. This is the library from where you pick stuff. This is just a library browser. It should show another simulink. Oh, great. Okay, so this is simulink. So this is another application, but it is inbuilt to Matlab. You can transfer code from one place to another. So we can take either a blank model, or you can take one of them from these toolboxes. We can take from communication, DSP system. DSP stands for digital signal processing. So you got communication systems and basic filter, mixed filters. We'll do an example over here. I'll be just playing an audio and trying to increase the bass of one of the audio files. Then you can see what's the difference between Matlab and Simulink. Anyone has any doubts? Mohammed Musmail, it's not clear. What is not clear? Muzamil, Mohammed Muzamil. Is there something which is not clear? You want me to repeat something? Oh, I guess he's offline. So we'll continue. If anyone has any doubts, you can unmute your mic and speak up. So next, next we'll go through. So next we'll create. I'll show you what's the difference in live editor and normal editor, live script and normal script. So this is a live editor, and this is a normal script. So the normal script is just you write a basic code. There's nothing like special text or something like that. Comments are added using this percentage sign. So if you want to add a comment, you just press tab and then percentage, and then you can write comment. That's how you write comments. But in a live script, the best part is that you can make it look like a textbook. So if you are, when you join your signal processing laboratory, if you give like this, it adds a different value. Like it looks like a textbook. You've got heading, you've got experiment 2, this is my name and roll number. Then I show what each section does. This is called a section. So we can ask Matlab to run one section only. So if I go here and this is one section, I can ask it to run this section. Can everyone see this? This is where I run the section. So either I can run this section alone, or I can run this section alone, or I can, if I press run and advance, it will run this section. It will run this section, and it will go to the next section and it will wait for you over there. Now, why is it important for you to run each section? Is that when you run all, when it is a normal code like something like this, and when you press run all, it will run the entire 34 lines of code at once, and you won't know as these workspace values are changing. So one way of making to see how the variable values are changing is to run it one by one over here in the command window. If that is not possible, then we add a breakpoint. Now, how do we add a breakpoint? We just go over here in the normal script and we ask it to stop over here. Can you see? I clicked one of these lines and then I can ask it to stop over here. So when I go over here and ask it to run, it's going to run and it's going to stop at this line. So I can see what is the status of all the variables till line 12. Okay, now we'll go and we will check out a simple code. I will be showing how to plot a sine wave, and to make it more fun, I'm going to show you how we can listen to the sine wave. I hope everyone knows of the format called MP3. MP3 is a widely used audio format. One of the other audio formats are WAV and then FLAC. So one of the format is MP3. So we are going to convert a signal to we are going to have a signal and we are going to listen to it, and we are going to see how it sounds like, and we are going to visualize that signal and see what's the difference when we change the sampling rate. Okay, so let's start. Mm, So, there, like, it's a good programming habit to use the full words instead of writing variables like a. Like you would have noticed over here, the variables I've given it a specific name: div a, div d, exp a, exp d. Because these codes I may have written 6 months ago. Now I don't know what does each line do. So a good idea of any programmer in any language is not to use single letter variable names. It makes your life easier, though it's a bit time consuming. So let's see. Let's begin. So one of the first things we start is something called a time base. So I'll create a time base, and I'm going to make it linspace. Mm, then space from 0 to, let's make it say 2 seconds. Okay, 2 seconds, and I want it to run at sampling frequency times 2. Now what does this line exactly do? I won't ask a question because everyone's mic is muted. uh, this linspace is a function. Okay, I'll show it in the command window. I'll increase the command window and I'll clear the workspace. How do I clear the workspace? I try to clear all. Clear all. Okay, now I cleared the command also. So let's see. Okay, fine. So when we want to create a matrix, we can either create as A is equal to square bracket 1 space 2 plus space 3 space 4 space 5, and I can close the bracket. Okay, this will create a matrix. You can see over here I have got a name A, and it has got values 1 to 5. Now what if you want to create a matrix from 1 to 100? Are you going to write A B is equal to square bracket 1 space 2 space 3 space 4? No, you are going to use something else. So one thing is you can use a colon operator. So you can say 1 to 10. Okay, and when I press enter, it is going to show B is now an array, a single 1 is 1 into 10 dimensional array, and it is a single dimensional array, and it is going to have 10 values. Okay, so if I want to create it from 3 to 10, or say 3 to 15, so I can say B is equal to 3 to 15. I was going to say 3, 4, 5, 6. So the difference is that the step size is 1. If anyone is fluent with Python, they know what's going to have what I'm going to say next. The next would be, you can add another colon operator and specify the step size. Okay. So say for example I want to show all the even numbers. So how will I show all the even numbers? So C is equal to 0. That's the starting. Then step 2. Then I'm going to show 20. Can you see all the? I have shown all the even numbers. How do I show all the even numbers? I asked it to step by 2. So it's going to go 0. Then it's going to add 2. Then again add 2. 4. Again add 2. 6. Now, what is the disadvantage of this? This will show. This colon operator will always show the starting value inclusive. If I write C is equal to 1 step 2 till 20, it is going to show 1, but it won't show 20. Can you see? Because as you add 2 to 1 and continue adding 2, you will never reach 20. You will reach 19 and then you will go to 21. So that is why we don't use linspace, because it skips this number 20. So what is another way of creating an array? That is called linspace. As I've written over here, linspace. Linspace stands for linear space. It creates equidimensional, equispaced numbers and puts it in an array. And if you want to know more, you can just go to documentation and ask linspace. Uh, the spelling is Linspace. All right. So this, and then if I ask linspace, so I can say C is equal to linspace, and what is the format for this? Format is starting, ending, and end. Starting, ending, and step. You can see it comes over here as I type linspace is showing the format. So I can show starting should be 0, and I want it to go till 10, and I want say 5 equally spaced uh, values. So this will give out 5 a single dimensional array having 5 elements. So as I press this, it's going to show 5 elements. Can you see it has shown 5 elements between 0 and 10, and it's going to be 0 and 10 inclusive. And that is why I use linspace in all my codes. Some people use this colon operator, but I find linear space more easy, and it reduces a lot of the headache. Now another very good idea mm, when you're working with MATLAB, when you're working with software like this, is you create variables for everything. So say for example in this, you can see I've got time base is equal to linear space from 0 to 2, and I've given Fs. Fs stands for the sampling frequency, and I've given it times 2. Why I've given this, I'll explain it soon. So another way I can do this, I can give a value called E and D. Now see, when I give E and D, it is showing is showing a blue text, and it's showing it there's some mistake. It's because end is a keyword. So instead of end, I'm going to use maybe end one. So now it is going to show that there's nothing wrong with it, and I'm going to give end one as 2. So I'm saying, so when I want to change uh, a parameter of this code, I can just change one value from the top. I need not change 2 everywhere. I just change the value stored in the variable, and that variable, as it is running, it's going to change all the values. So I can, over here also I can give n1 at fs times n1. Okay. Now, if you want, you can run this only. It's going to say where do I want to save it. I'm going to ask it to save in Matlab, and somewhere out here, untitled. I'll give it IEEE and give it save. Okay, unrecognized variable or function fs. I've not given fs. Now we'll give fs. Say fs is equal to 1000. Now, if I can give 1000 like this, or I can give 1000 as 1e3. I hope everyone is familiar with this expression. E stands for exponent. It's not that e 2.7 something. It is e like 1 into 10 raised to 3. That is what this thing means, 1e3. So if I want sampling rate of 10 kilohertz, I can write 1e4. I need not write 1 and followed by 4 zeros. I give 1e4. This is my fs, and this is going to be my time base. Now I will explain why did we write this this line. So what if I don't write end L over here and I give fs over here? What it means is that it is going to create fs time number of elements between 0 and end L. Or in more normal terms, if I give it say 10, and if I give fs as say 1000, what this line does is it is going to create an array starting from 0 and ending at 10, and it is going to have 1000 elements in between. Now there's a problem in this. MP3 format, the sampling rate is 44.1 kilohertz. Now, if I want to create 44.1 kilohertz, and that is kilohertz means samples every second, I can't calculate how many samples should there be from 0 to 10. It should be 10 into that sampling frequency. So that is why I have given over here, I'll give sampling frequency into end 1. Over here, I can also change it to end 1. Now, what this does is, in between every two numbers is going to create fs times of samples. So this is very useful if you want to listen to the signal you have generated. Listen is actually listening using the tone, using your computer speakers. So now that we have created a time base, we can run it and see if the time base you created is correct. Yep, I wanted a 2-second one, so it has got created 20,000 elements. Okay, good. Now next, which wave do we want? So let's say we want a sine wave. So what are we going to give? We're going to give sig. Sig stands for signal is equal to, sig is the variable name. You can give whatever variable name you want. I have given it sig. You can give it maybe whatever you want. So sig is equal to sine of 2 star pi star. Now, what is the formula? 2 pi t, right? And t stands for the time base. So I'm going to give time base. And now, if you'll be thinking, how can we multiply a normal uh, integer with an array? So this will give an error. So one easy form of how do you multiply a scalar with a vector or an array? We use something called a dot product. Now this next thing is very easy. Now, so therefore, how do you multiply a scalar and a vector? You can say dot product. So dot product. So we put a dot and then we do the product. So now we have got 2 pi this, and now we need to create a frequency. Now, at what frequency do we want to listen to this? So let's say let's name this signal 1, so that I don't have to change it later. I'm going to give it frequency 1, okay, f1, and then I'm going to close this bracket so that this multiplies this thing first, and then it multiplies with the time base. Now you will be seeing there's a orange warning over here. It is there because I've not given the semicolon. Now, what is the importance of the semicolon? As you see over here, if I create an array, A is equal to 1 to 5 and I press enter, it is going to show the entire array. But if I don't want it to show after it works through each line, is I will put a semicolon. So I'll put A is equal to 1 to 5 and I'm going to close it, the semicolon. Now when I press enter, it is not going to show anything. Now, when you're beginning with Matlab, one of the easy things, one of the biggest mistakes you can do, you'll create a time base as, let's say, t base is equal to, let's say, 0 to say 1000, and you forgot to put a semicolon. Then what happens? When you press enter, it's going to create something like this, and your entire command window, you can see what's the previous command you put. So that's why we always put the semicolon. So we put C and close here that. Okay, fine. So now this will again show an error because I have not given what is F1. So we can give F1 as name of frequency. Let's give 2 kilohertz. So we can give it 2E3, 2 kilohertz, and then its signal 1 is sine 2 pi and time base. I think this should be okay. Well, let's press run and see what happens. It's showing busy over here. If you can see, it's showing busy. Okay, fine. So this is So time with a small mistake. Okay, so what is the mistake over here? You can see I have given time base with a capital B and here with a small b. So we change it to capital B and then we run it again. Yeah, now it has run successfully and I think SIG1, yeah, a proper signal has come over here. Okay, now this signal, okay, fine. You can, if you want to see what this signal is, you can double click over here and it's going to open Excel type or something. It's going to show what are the values stored in this array. You can see these are the values stored. So you can see there are so many elements in this, and it is showing how the sign is going to go through it. Okay, so this is your the thing the sine wave which we created. Now, how are we going to view this? So we are going to ask it to plot. We are going to ask it. So what is the format for plot? Plot is x and y. So I'm going to give time base x comma y. What is y? That would be sig1. I press enter and I ask it to run. Okay, fine. So this is the sine wave. Now, why is this so large? Why doesn't this look like a sine wave? It is because we have given the sampling frequency very high. So therefore, there are so many. The frequency is so high that between 0 to 2 seconds, there are so many sine waves in this. So one way you can visualize this is you take the zoom in button, zoom in key icon, which is over here, and then you can ask it to zoom between this, and you can see all the sine waves over here. Now, why is this sine wave so haphazard? Now, this is where the sampling comes in. Now, because the sampling I have given is at 10 kilohertz and this is running at 2 kilohertz, it's going to take about 3 or 4 samples between each wave. If I increase it further, then I'll be able to see a proper sine wave. That is where the resolution comes in. So we are going to open. Okay, fine. So over here, I can change the sampling, and if I put it as 1 kilohertz. Okay, now you see the wave is at 2 kilohertz, and I'm sampling it at 1 kilohertz. Now you won't be able to make it out what kind of is it a sine wave or a square? Oh, huh. Fs. Okay, it's because I put handle over here. If I change sampling frequency to say 1, fine. Okay, so in this 6 lines, what are we going to look at? So we are going to look at the sampling frequency. Sampling frequency should be 1 kilohertz, and the signal frequency is 2 kilohertz into time base. Time base is fs into endl. Okay, I'm going to close this endl and I'm going to further decrease it. Okay, 2, and then how many that thing do we have? We have got 1000. Okay, what if we decrease it further? We are going to make it 500. There seems to be a small problem in this. I can't figure it out. So what is supposed to happen is, as you go to my experiment 1, I'm going to increase this. So it is supposed to show something like this. Okay, now I'm going to run it over here itself. Run. Okay, now over here, if I ask it to plot this thing, what is this one? This one should be sine D. Yeah, sine D. If I ask it to plot sine DI, sine capital D, yes, capital DI, and ask it to plot it. Yeah. Okay, as you can see here, now this is not a clean sign. Now what this is doing is, it's going to, this plot, what it's going to do is, it's going to take the values and it's going to mark the dots over here, here, you can see the dots highlighting, here, 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 and all these dots, and it's just going to join it with a straight line. So now, that's why it's somewhat looking like a sine wave, but it's not as a clean high resolution sine wave. So another wave, if we increase the sampling rate, is going to look like a more clear sine wave, like something like this plot. Okay, fine. So x, y, we're going to close and this delete y. Okay, fine. I figured out what the problem is. Okay, so now if you look over here, now this is going from 0 to 2 and it needs, say, 5, it's going giving 5 samples between 0 and 2. So now when we run this from, hmm, it's going to show 5 values, and at each value it is going to give a point. Okay, and this is why your sign looks a bit bad. And if you want to see the digital, I'm sorry, I'll turn off the fan. If you want to see the digital response of this, you can ask it to stem. Sorry, stem, and then when you run it, okay, now here you can see these are going to negative values. You can see the axis over here is 0 and is going to negative. These are the values. Okay, and now now that that is over, plotting is over, we are going to go through something called the functions. So all the functions you can see over here, you can run all the functions whatever you feel like. Like if you want to listen to, if you want to listen to an audio, you can use an audio function, and that is uh, kept over here. It's called audio player. So this is one song. So I can ask it to Control C, and I can paste it over here. FSMP3 audio is at 44.1 kilohertz E3. I'm going to make it run for 2 seconds. FS star and N. Let's see what's the documentation for linear space. If anyone has any doubt, they can always ask me. Now everyone is mute. Nice. Ah, this is a processor. I think my net is a bit bad. Linear space. Yeah, linear space. Okay, so this is how you read the documentation. It's going to go show the syntax x1, x2, and n. Yeah, looks about right. Now audio, I am going to ask it to play SIG1, SIG1, and FS is my sampling frequency. And when I press run, then I'm going to remove this. End L. Okay, fine. End one, SIG. Okay, now I'm going to go back. Okay, so I heard a tone. Did anyone else hear the tone? Now, since it is running for 2 seconds, it was a very short tone. I think it's because we are using the same mic. Okay, fine. So a tone is supposed to come. So let's see if it runs for this. This is a song. Change folder. Oh, fine, fine, fine. It play you. Okay, fine. So how I got these commands are from the documentation. So over here, if you want to listen to this tone, you need to run it again, and we'll ask it to play you. Could everyone hear this tone? Ask it to play it again. I don't know if you are able to hear this tone. It's a high pitched tone because we are given the frequency of 2 kilohertz. Our hearing range. Hello, yeah. Did anyone unmute their mic? I guess not. Okay, so that is that, and now we are going to go through. Did anyone have any? Yes, good here. Okay, fine. Thanks a lot. Uh, Matlab. Okay, now if you want to see what are the frequencies present over here, we are going to do something called a Fourier transform. So this tutorial will be divided into two parts. One is for introduction and the other is for signal processing. We'll have a small break in between. Now, once that this Matlab is, I hope everyone is clear with this, even though this sampling thing, I could not show it live, some error in the code. Now, I can always show you Simulink. The Simulink is another software. Uh, and I'm going to run a small code in this. Where is it? I'm going to ask audio. I'm just going to create a blank new. I'm going to ask you to create a blank model. So this is what Simulink looks like. Now, what's the difference between Simulink and Matlab is that I can run what you say the signals everything in real time. Over here, once the program starts running, you can't do anything to it. But over here, this is not the case. You can change it. So now, how do I add things over here? I can either go to library browser, and I'm going to create a normal what is a spectrum analyzer. So we take a spectrum analyzer, we place it over here. We take an audio device writer and we put it over here. We increase this. Sources, we're going to give it from multimedia file. I'm going to keep it over here. Okay, now for any wave, if you want to do anything to it, you can double click and you can change its characteristic. This is applicable to any your block in Simulink. So if I want my song, I need to select my song. So I go to I think some documents, Matlab, examples, R2019B, nav, this one, song one, and open it. I'm going to press apply. Now see what's this. Okay, fine. I will say apply. Okay. See, now you can see what's the frequency of an MP3. This 44.1 kilohertz. Now this shows the sampling rate, and now I'm going to connect it. How to connect two different blocks? I take this and I connect it over here. I take one from, or I take one from here, and I will connect it over here. Now, or in Simulink, if you want to add anything other than going to library browser, say I want to add an amplifier or a gain, I can just click over here and type GAI. It's supposed to come. Yeah, GAIN. I can gain and I can put an amplifier. It's going to say how much gain do I want. So I would say 1.5. So this is the gain. Now, how do we run this? So over here, I'm going to stop time. It is going to run for 10 seconds and then it's going to stop because it's a big song. So if I press run, we can take any audio. I chose this song to make it a bit more interesting. This is, otherwise it's a bit boring. So I take run. Run simulation. See, this is the spectrum of this sound. This is the high frequency, this is low frequency. And when the bass hits, okay, fine. That 10 seconds is over. I'm going to make it to 30 seconds. Okay, this is spectrum. Now, if we're going to ask it to show peak finder. Okay, now see, you can, when the bass is hitting, the low frequency is getting amplified over here. See that when the bass comes, it's going to, the low frequency is going to boost up to over here, and this is all the high frequency. Now you can see there's a roll off over here. This is somewhere around at 20 kilohertz. The audio is nothing, so therefore you can't see anything. Now, how do you visualize this? There's something called a fast Fourier transform or a Fourier transform. It is used for transformation from one domain to another. That all we'll see in the next session. If the people who are interested in signal transformations are there, we'll take that in the next session. Over here, we'll be looking at simulink. So this is simulink. I can add a gain. Now, you know filters. Now, how to add a filter? I can type. If I want to increase the bass a bit more, I can add a low pass filter. So I put low pass filter. I'm going to ask it to take the audio from here, lower the, take the low frequency audio and then feed it back. And then I can't just simply feed it back. I need to add a some. Okay, see, and now I'm going to delete this. This is going to go to this. I'm going to boost the bass, feed it over here, and then I'm going to for everyone's easy, so that everyone thinks that this is still understandable. I'm going to put it in some different places. Okay, I think that this sounds. Yeah. So what I'm doing, I'm taking the song, I'm going to feed it through a low pass filter, and I'm going to increase the bass by 1.5 times, and I'm going to feed it to a summer. So whatever the song is, it's going to add the bass, and then it's going to sum it, and then we can see that in the what they say in the spectrum analyzer. Now we can run it here. We need to give the specifics for the low pass filter. I double click it, it's going to say FIR or IIR. So FIR is for finite impulse response, IIR is for infinite impulse response. That and all electronic students, you will learn it in a subject called digital signal processing, not in signals and systems. So passband edge frequency, I'm going to give it say 40 hertz, and stop band edge frequency, I'm going to give it say 500 hertz. Okay, input sample rate for 4.1 kilohertz. I'm going to ask it to apply. Okay. Again, I think this should be okay. Now let's run it. It's running for 30 seconds. Now you can see already the bass sometimes it's reaching over here. Okay, now it's going outside the graph. Now, and I can hear this as extremely distorted because that's how the software is. So we'll stop this. Okay, fine. Now over here, oh, did I close? Yeah. Now you over here you can see there are two lines. One is blue and one is yellow. What is the two lines? So therefore channels. This song is a stereo song, so therefore we have got left and right channels. and these are the two different channels over here. And as the song goes, as the song is recorded, each channel is recorded differently, so that's why you can see both of them are misaligned, and at high frequency they are somewhat aligned. You close this. If you want to see how this song is, we can go over to, back to Matlab test one where I've loaded the song, and it should be there in song. Yeah, we go to song. This is showing what's the contents of the song. So over here you can see what is the song. So it, since it is going at 44.1 kilohertz, the starting of the song is silent. So you can see zeros. So what are the two columns? The two columns are left and right audio channels. So you can, as you go down, you can see the song is picking up. These are some valid tones which are coming. Now this is the same way. This is the same thing which we did for our when we created a tone in this one, where we created a tone for our sine wave. I think with this we have come to an end. Yeah, we also have plots, data and all. We'll look in the next session for people who are there for signal processing. Mm, Plots, titles, if and if else. So there's something called if and if else, like they are all condition. What they say, branching, and for if you have a if, or you want to ask a question, or you want to give a condition, you can put if and if else. We've got while, we don't have do while. We have got for loops, and those are all the things. If you want to look at their syntax, you can always go to the documentation over here, and you can search for loop, and it's going to show for. It's going to show over here. This is, and also one more thing. When you look over here, it's showing fx. This is for Matlab. If it's showing a box with an x in the middle, it is for Simulink. So if I go for audio, audio, or let's say f spectrum, FFT. Oh, I can't get it. A scope, SCOPE. Okay, they are all showing FX, but if it is instead, okay, filter the functions, nice. If it is showing a box with an area, this one. If it is showing something like this is not the you need not click it, because this is showing the documentation for a scope in Simulink, not for Matlab. And this is documentation, just theory. And this is the actual function. Okay, so those are a few key tips. This is the help. I think that's about it. We can always go to live script, and I can show you what live script is. So in live script, you can. Oh, I have already shown you live script. It's on here. Experiment 1, 2, and 3. So this is implementation of LTS systems. If you want, I'll maximize this. Okay, so this is showing LTS systems, and if I want it in the PDF format or in the nice textbook format, I can click over here for output inline. So it's to show the plots after each uh, what to say, after each time I ask it to plot, it's going to show me the figure. So this is live editor. I think I have completed everything which was there in my book. If you have any doubts, you can ask right now.
Hello. Okay,
Yeah, Krishna.
thank you, Anchal. We will go ahead and take some times for the questions.
Mhm.
You can unmute your mic and ask him directly.
Okay, good. I'm going to stop presenting.
Or you may put the questions in the chat box.
Uh, how do I change the camera? So anyone has any doubts regarding Matlab and how to work with it? I'm going to again start my screen sharing in case my entire screen, so that you can look at it and ask for doubts in it. Anyone has any doubts? Was anyone working through as we were saying? Does anyone want to explain this, or let's say this uh, experiment? I think this is one of the first experiments. The first experiment is introduction to MATLAB. It's full theory. This is the first thing which we actually do in MATLAB. So if you want, I can explain this one. Anyone's there? Okay, I guess no one has any doubts. I think Binu ma'am is online. Ma'am, would you like me? Would it be okay if I have to explain that thing, that experiment? In the first experiment, it shows the plots and everything.
I joined a bit late, Anchal,
Oh yes, ma'am.
so I didn't pick up the first part. I think the last part was fine, showing the uh,
Okay, so
plotting.
I will. Okay, Simulink was fine. Oh, that is okay. Oh, that's okay. I think I'll take this thing, but it would be nice. Everyone will get a quick recap as to what we did today.
Yeah, and
So this
as
is,
for
yeah.
students, I don't know how many of them have started using Matlab. So get into Matlab only, then you get the feel of it.
Oh yes, that's true. I asked them in one of the prerequisites. I asked them to install MATLAB at least 2013B onwards, so that they
Huh.
can go do it as we are going through, as I'm explaining.
Yes, good
Okay,
attempt.
so
Yeah.
we'll go through the summary of this code. So in this code, we are going to generate some signals. The signals are going to be sine, I think square. Then we're going to show all the digital also. We are going to be showing impulse, step, exponential, and sine waves. So what's the first thing we do? We do some initializations. So these are the initializations I've given. I've shown what's the divisions I want. So division for digital I have given 11. A division for analog I have given 1001. Why we have given one? Is so that it's even. Um, even like in that wave, it looks it's inclusive of both the ends. As you do this code, you will understand why we give 1001 and 11. If you don't give also, it is okay. Just that your wave will be cut short a bit earlier. Okay, now first time base A. This is time base for the analog and time base for the digital. I am simulating for 0 to 10. I am using lin space. What is lin space? Lin space stands for linear space. It creates an array from 0 to 10 having div a time many spacings. Okay, like divide many elements are there in this array. So time base A is going to have 1001 elements. If you go to time base A, is going to have 1001 elements, and time base D is going to have 11 elements, as you can see over here. Now impulse. So this is an impulse wave. Okay, fine. So I'm going to how do I create an impulse wave? What is an impulse wave? Impulse wave. I need not draw. I already have it over here. This is an impulse wave. It shows one. It has a value of 1 at 0, and then 0 at all the other instances of time. So you can see over here at 0 it is 1, and at all the other instances of time it is showing 0. So this is an impulse wave. So, so how do we show this impulse wave? My mouse battery is not over, so I'm using the trackpad. So how do we show this? So one of the easy, instead of using a function, what can we do? We can ask it to plot, make an array of all zeros. Now how do we make an array of all zeros? I can make an array of all zeros. Say A is equal to zeros of one dimensional and 10. So it's going to create an array of zeros only from of 10 elements. So 1 comma 10 means one cross 10 dimensions. If I want to create a 2 cross 10 dimensional zero array, I can create A is equal to 2 cross 10. Now I've created an uh, what to say, a zero array, zero matrix like this. What if I give only one argument? Then it's going to create a square matrix of the dimension whatever is inside the argument. So A is equal to zeros of 3. So this is the matrix which you get. So that is what I've used over here. So I created an array of having only zeros from 1 to div A. Okay, and then I'm asking the first element. Now how do we address each element? We use normal brackets. We don't use square brackets. We use normal, the normal bracket which we use. That's the difference between MATLAB and C++ and all the other computer programs. And another big difference is that all the array elements start at 1. They don't start at 0. So this is going to create lots of problems as we go, as you write codes, because we are all used to writing the for loop from 0 to 10 or 0 to the last number. Whereas over here you need to start it from 1. It's a very important point. In MATLAB, the array's index starts at 1. It does not start at 0. So that is what I have done over here. I've set impulse A at 1, it is the value should be 1. And that with that I'm done for this wave. Then I've got for impulse in the digital domain, I have created this same thing, zeros from 1 to div D, and I've given the first value as 1. Then ask it to plot both of them. So this is the function for it, plot x comma y. So x is time base and y is impulse, or y is the signal. So the signal is impulse A. So this is the amplitude, the impulse amplitude. Now if you want, we can create a small thing. Can we add a breakpoint over here? Run to here. No, I don't think we can. You were supposed to section break. Okay, fine. And then over here we can give another section break. Okay, fine. So now when we run this section, only this section is going to be run. And over here, if I give division A as say 10, you will see it actually div A is equal to 10 if we give, and if we run this section, vectors must be, oh fine, there's a small error. Okay, what happens is it's going to show a straight line from here to 1, because this is a very high resolution graph. It is the slope, you can't make it out, but there's an actual slope which goes from here till the next value, and you can see that slope as as the resolution decreases. You can see that slope. Say for example over here in this digital impulse signal, if you plot this is going to be impulse D. If I plot impulse D, yeah, see, you can see the slope over here. This is a low resolution impulse graph. You can see from 0 the next value is at 2, so therefore it draws a straight line. Okay, now that is impulse. Next we go to step response. What is step response? Step response is a signal which has got 1 for all value for time greater than 0. This and all you will learn in signals and systems. You can see this is an analog step signal. At 0 it is supposed to be 0, then it climbs to 1 and now it is going forward. Okay, at 0 also it is supposed to be 1, yeah. And anything less than 0 it is going to be 0. This is a ramp signal. Ramp signal, we use the function called uh, I think it's called ramp or something. No, it's called triangle. Uh, no, for ramp signal, you just create a normal what do you say? A normal normal array from 0 to say what 10. So how do we create such an array? Such an array, yeah, is a is equal to 1 to 10. Now this is a now as a ramp signal. Now if I plot a, I should be getting a ramp. Yeah, this is a ramp. The triangle thing that comes for triangular waveforms and okay, that is not given in this question. Okay. This is the exponential waveform. For exponential also, the functions exp. It should be there somewhere here. Yeah, expd. Yeah, expd is exp of time-based d. And similarly, you just ask it to plot and then give the title, x label, y label. Don't forget to put this single colons, and that is used to mark what is a string. The string is a uh, collection of letters. This is the sine waveform, and this digital sign. I hope with this everyone is gets a basic idea as to how to work with MATLAB. Some basics. One of the best things you can find in MATLAB is this documentation. This documentation has been written in an extremely professional manner. It is uniform throughout the different versions. So if you have any problem with any function, please go through the documentation. It helps everyone. It helps a lot. It helps me a lot. When we are in the laboratory and you're working on it, you can always ask the help to be docked somewhere over here. I ask scope, and you see this arrow. This asks this window to be docked. So this window is going to be docked over here, and oh God. Yeah, and then I can ask it to move over here, and then as I increase this size, this window is always going to be with me, even when I'm coding, and I can refer to this window whenever I have any doubts. And all the best. If you're interested, we'll go to the second session after a small break. Krishna, you're online.
Hello. So, Aanchal, are you over with your
Yeah,
session?
Krishna. Yeah, I'm over with the first session. If everyone, Anju ma'am asked for something for transformations and all. So that like continuous transformation is out of scope for this. We can show some digital transformations. That's all.
Okay.
Okay, so everyone, please unmute your mic. Manas, Naufal, Rupa, Siddhartha, Smriti, you can stay muted. Sony and Yuyush, please unmute your mic. Yeah, good. How was the session? Was okay. You don't have microphone now. Fal, it's okay. Rupa, how was the session?
Jada, actually, I was not that much familiar with Python, so it was a bit difficult for me to understand.
You want me to repeat any topic? I was planning on taking this as an offline class before the corona fiasco started. അതുകൊണ്ട് നമ്മളിപ്പം ഓൺലൈൻ ആക്കിയത് ഇവിടെ ഇരുന്നിട്ട് ഞാനും പോസ്റ്റ് നിൽക്കുമായിരുന്നു ആരും കാണാനുമില്ല.
Ah,
Krishna,
so
Gauri, you're there or you're offline?
Yes, I'm there.
Okay, fine.
I'm there.
Said നല്ല ബോറായിരുന്നോ?
അല്ലല്ല, മനസ്സിലായില്ല. എന്താ അത്യാവശ്യം കാര്യമായിട്ട് മനസ്സിലായിട്ടുണ്ട്. ഞാൻ മറ്റേ മാറ്റ്ലാബിന്റെ അസൈൻമെന്റ് ഉണ്ടായിരുന്നപ്പോ തട്ടിക്കൂട്ടി ചെയ്തു. ഇപ്പൊ എന്തൊക്കെ ഐഡിയ കിട്ടി.
ഇതിനകത്ത് വലിയ പ്രോബ്ലം ഉണ്ടെങ്കിൽ ആ ഡോക്യുമെന്റേഷൻ പോവാണെങ്കിൽ അത് നന്നായിട്ട് എഴുതി വെച്ചിട്ടുണ്ട്. അത് ജസ്റ്റ് നമുക്ക് ചില കാര്യം മനസ്സിലാക്കേണ്ടത് പറഞ്ഞാൽ അത് ഞാൻ കുറെ പ്രാവശ്യം പറഞ്ഞതിന് അതാണ് എന്താ പറഞ്ഞ സാമ്പിളിംഗ് ഫ്രീക്വൻസി ഭയങ്കര ഇമ്പോർട്ടന്റ് ആണ്. ആ സാമ്പിളിംഗ് ഫ്രീക്വൻസി നമ്മള് ലോ സാമ്പിളിംഗ് ചെയ്യാൻ നേരത്ത് പ്രശ്നം പറഞ്ഞാൽ എന്താണ് ഏലിയാസിംഗ് പറഞ്ഞ കാര്യം വരും. ഏലിയാസിംഗ് വരാനത്ത് നമ്മള് ഫോറിയർ ട്രാൻസ്ഫോം ചെയ്യാനത്ത് അതെല്ലാം തെറ്റായിട്ടായിരിക്കും വരുന്നത്. ഇത് അപ്പം ദാറ്റ് ഇസ് അതൊരു കുഞ്ഞൊരു പ്രശ്നമാണ്. പിന്നെ വേറെ നമുക്ക് കണ്ടിന്യൂസ് വേവ് ഫോംസ് ഇതിനകത്ത് സിമുലേറ്റ് ഒട്ടും ചെയ്യാൻ പറ്റില്ല. അപ്പൊ അതും ഒന്ന് ഓർക്കണം. നിങ്ങൾ ഇത് റൺ ചെയ്യാനായിട്ട് കണ്ടിന്യൂസ് വേവ് ഫോംസ് നമുക്ക് റൺ ചെയ്യാൻ പറ്റത്തില്ല. ഓക്കെ ഫൈൻ.
വേറെ ഇല്ല, മനസ്സിലായി. ഇപ്പൊ ചേട്ടൻ പറഞ്ഞ ഇത്രയും ക്ലിയർ ആയിട്ടുണ്ട്.
ചില കാര്യം എനിക്ക് ചെയ്യാൻ പറ്റില്ല. ലൈക്ക് ഫോർ എക്സാമ്പിൾ ഞാൻ വിചാരിച്ചാൽ രണ്ട് സൈൻ വേവ്സ് നമുക്ക് ആഡ് ചെയ്തിട്ട് അതിന്റെ ടോൺ നമുക്ക് കേൾക്കാൻ പറ്റും. ഹാർമോണിക്സ് കേട്ടിട്ടുണ്ടോ? ഹാർമോണിക്സ്. അപ്പൊ നമുക്ക് രണ്ട് സൈൻ വേവ് ആഡ് ചെയ്തിട്ടാണ് ഹാർമോണിക്സ് നമുക്ക് കേൾക്കാൻ പറ്റും. അത് ഞാൻ ചെയ്യാൻ വിചാരിച്ചു. പക്ഷെ ഇവിടെ എന്താ പറയുക, എന്റെ മൗസിന്റെ ബാറ്ററി എല്ലാം തീർന്നു. അപ്പൊ ഞാൻ വിചാരിച്ച് ജസ്റ്റ് എക്സാമ്പിൾസ് ഒക്കെ കാണിക്കാം. സിദ്ധാർത്ഥ് ഓൺലൈൻ? സിദ്ധാർത്ഥ് സിദ്ധാർത്ഥ മൈക്കിലുണ്ട് പ്രശ്നം. ഓക്കെ ഫൈൻ. എന്തായാലും എല്ലാരും മ്യൂട്ട് ആയിരിക്കും. നമുക്ക് എന്താ പറയുക, ട്രാൻസ്ഫോർമേഷൻസ് പറഞ്ഞൊരു കാര്യമുണ്ട്. നിങ്ങളുടെ 5 മിസ് പറഞ്ഞു അത് എടുക്കണം. അതിനെപ്പറ്റി ഞാൻ കുറച്ചൊക്കെ നോക്കിയിട്ടുണ്ട്. പക്ഷെ അത് പറഞ്ഞ മാറ്റ്ലാബിനകത്ത് നമ്മൾ വളരെ കുറച്ച് ചെയ്യണുള്ളൂ. LTI ട്രാൻസ്ഫോംസ്, LTI സിസ്റ്റംസ് ഉണ്ട്. പിന്നെ Z ട്രാൻസ്ഫോമിനകത്ത് നമ്മൾ ചെയ്യാറുണ്ട്. വേണമെങ്കിൽ ഞാൻ പറഞ്ഞു തരാം. ഈ ട്രാൻസ്ഫോംസ് എന്താ അതൊരു ബേസിക് നമുക്ക് ജസ്റ്റ് കുറച്ചൊരു മനസ്സിലായി നമുക്ക് അതിനെ പിന്നിലത്തെ ഐഡിയ എന്താണെന്ന് മനസ്സിലാവും. പ്രോബ്ലം വിത്ത് മൈക്രോഫോൺ. ഓക്കെ. അപ്പം അത് ഇപ്പം ചെയ്യണോ അത് നിങ്ങൾ എല്ലാവരും ഫുഡ് കഴിച്ചിട്ട് വരണോ അത് മതിയോ?
ആഞ്ചൽ, അത് വേറൊരു സെഷൻ ആയിട്ട് വെച്ചാലോ?
പിന്നെ സിഗ്നൽ സിസ്റ്റം എനിക്ക് ഇഷ്ടമുള്ള സബ്ജക്ട്.
അതല്ല, ഇപ്പം പാർട്ടിസിപ്പൻസ് കുറവല്ലേ? അപ്പൊ എല്ലാവർക്കും കേൾക്കുന്ന രീതിയിൽ പിന്നീട് ടോപ്പിക് അറിഞ്ഞോണ്ടേ.
ഓക്കെ, ഇയാളുടെ ഇഷ്ടം. സിഗ്നൽ സിസ്റ്റംസ് വേണമെങ്കിൽ വേറെ ഒരാളുടെ കൊണ്ട് ട്രാൻസ്ഫോർമേഷൻസ് ഒക്കെ വേറെ ഒരാളുടെ കൂടെ എടുക്കാനായിരിക്കും നല്ലത്. മാറ്റ്ലാബിനകത്ത് നമ്മൾ ചെയ്യുന്നതെന്ന് പറഞ്ഞാൽ ഫാസ്റ്റ് ഫോറിയർ ട്രാൻസ്ഫോം പറയുന്ന കാര്യമുണ്ട്. കൃഷ്ണയ്ക്ക് അറിയായിരിക്കും. FFT. അതിനുവേണ്ടി നമുക്ക് ട്വിഡിൽ ഫാക്ടറും ട്വിഡിൽ മെട്രിക്സ് ഒക്കെ അറിയാം. അതൊക്കെ ഒരു വലിയ ചെറുതായിട്ട് ഒരു വലിയൊരു ടോപ്പിക്കാണ്.
അപ്പൊ അങ്ങനെ ഒരു സെഷൻ വെക്കുമ്പം സെക്കൻഡ് ഇയേഴ്സ് എല്ലാരും കുറെ കൂടെ ആൾക്കാർ കേൾക്കുന്ന രീതി വെച്ചാൽ കുറച്ചുകൂടെ നല്ലതല്ലേ?
വേറൊരാളെ കൊണ്ട് എടുക്കണം.
നിനക്കെടുക്കാലോ.
എന്നെ കൊണ്ട് സിഗ്നൽ സിസ്റ്റം പറ്റൂല. മാറ്റ്ലാബ് ആണെങ്കിൽ പിന്നെ, പൈത്തൺ ആണെങ്കിൽ പിന്നെ, റാസ്ബെറി പൈ അതും കുഴപ്പമില്ല. പക്ഷെ സിഗ്നൽ സിസ്റ്റംസ് പറ്റൂല. താങ്ക്സ് ബ്രോ. ഓക്കെ ഫൈൻ. അപ്പം നമ്മൾ ഇതോടെ അവസാനിക്കാം. മാറ്റ്ലാബിനകത്ത് ആരെങ്കിലും ഓൺലൈൻ ആണെങ്കിൽ ഞാൻ വെറുതെ എന്താ ഞാൻ രണ്ട് സൈൻ ഒന്ന് ആഡ് ചെയ്യാൻ ഞാനൊന്ന് ഇപ്പൊ ട്രൈ ചെയ്യാം. ആർക്കെങ്കിലും വേണമെങ്കിൽ അത് കേൾക്കാം. ആ ടോൺ കേൾക്കണമെങ്കിൽ. ഇത് ഇപ്പം എല്ലാവർക്കും വേണ്ടി കാണാൻ പറ്റുന്നുണ്ട്. set2 is equal to
കാണാം.
2 star I star F2 dot star Now we are നമുക്ക് F2 എന്നൊരു വാല്യൂ കൊടുക്കണം. F2 is equal to ഇത് 2 kilohertz ആണെങ്കിൽ അതിന് അടുത്ത ഹാർമോണിക് ആയിരിക്കും let's say 4 kilohertz. അപ്പം 4 E3 FS 44.1 audio player. Okay, fine. Now we are going to give signal is equal to sig1 plus sig2, and this we are going to give as sig. And when we run play, or error vanilla. But now we are going to listen to the tone. എല്ലാരും കേട്ടോ? അത് ഇനി നമ്മൾ അതിന്റെ F50 എടുത്തിട്ട് അതിന്റെ വാല്യൂ നോക്കാം. So FFP of plot ചെയ്യാം. Plot FFP of sig dose absolute എടുക്കണം. Yes. ഇതും നിങ്ങൾക്ക് പറഞ്ഞു തരാം. നമ്മൾ ഇങ്ങനെ ഒരു കാര്യം ചെയ്യാനായിട്ട് ഇതിനകത്ത് പ്രശ്നമുണ്ട്. പ്ലോട്ട് ചെയ്യാനായിട്ട് വർക്ക് സ്പേസ് ഇത് കണ്ട FFT ഓഫ് സിഗ്നൽ പറഞ്ഞ ഒരു കോംപ്ലെക്സ് ഡബിൾ ആയിട്ടായിരിക്കും കാണുന്നത്. V is equal to when we run this. Okay, fine. V is a complex double. ഇത് കണ്ട കോംപ്ലെക്സ് ഡബിൾ ആയിട്ട് കാണിച്ചിരിക്കുന്നത്. ഇത് നമുക്ക് പ്ലോട്ട് ചെയ്യാൻ പറ്റില്ല. അപ്പൊ നമ്മൾ എന്തോ ചെയ്യുന്നു പറഞ്ഞാൽ ഇതിന് ആബ്സൊല്യൂട്ട് വാല്യൂ എടുക്കും. ABS absolute of FFT of signal. ഇത് എടുക്കാനായിട്ട് അതിന്റെ ആബ്സൊല്യൂട്ട് വാല്യൂ ആയിട്ട് നമുക്ക് അത് എടുക്കാം. നമ്മളിത് റൺ ചെയ്യാനായിട്ട് ഇത് പ്ലോട്ടും ചെയ്യാം. പ്ലോട്ട് V. അപ്പൊ നമ്മുടെ ഇതിനകത്ത് എന്തൊക്കെ ഉണ്ട്? നമ്മുടെ 4 kilohertz ഉണ്ട്, 2 kilohertz ഉണ്ട്. അപ്പൊ ഞാൻ ഇവിടെ വെക്കുവാണെങ്കിൽ ഇത് 4 kilohertzന്റെ നമുക്കത് കാണാൻ പറ്റുന്നുണ്ട്. പിന്നെ ഇത് ഇപ്പം ഇത് 8 kilohertzന് വരുന്നുണ്ട്. അപ്പം അതിന്റെ ഒരു ഹാർമോണിക് ആയിട്ട് ഇത് അതിന്റെ ഇമേജ്. ഐ തിങ്ക് ദിസ് ഇസ് ഇമേജ് ഫ്രീക്വൻസി, അങ്ങനെ എന്തോ ഒരു പേരുണ്ട്. നമ്മൾ ഇത് ജസ്റ്റ് മിഡ്വേ എടുക്കുന്നുണ്ട്. ഇതാണ് അതിന്റെ സ്പെക്ട്രം. സ്പെക്ട്രം പറഞ്ഞാൽ നമ്മൾ എന്തിനാണ് ട്രാൻസ്ഫോർമേഷൻസ് ചെയ്യുന്നതെന്ന് പറഞ്ഞാൽ നമുക്കതിന്റെ സ്പെക്ട്രം കാണാൻ വേണ്ടിയാണ് നമ്മൾ അതിന്റെ ട്രാൻസ്ഫോർമേഷൻസ് എടുക്കുന്നത്. നമ്മൾ എപ്പോഴെങ്കിലും ക്ലാസ്സിനകത്ത് പോകുന്നത് നമ്മളുടെ കോളേജ് എപ്പോഴെങ്കിലും തുറക്കുവാണെങ്കിൽ ഇതിന്റെ ഒരു ഓഫ്ലൈൻ ക്ലാസ് എടുക്കാം. അപ്പം കുറച്ചെങ്കിലും നന്നായിട്ട് ചെയ്യാം. എല്ലാവരും ലാപ്ടോപ്പ് കൊണ്ടുവന്നിട്ട് നമുക്ക് ഇതെല്ലാം ട്രൈ ചെയ്യാം. ഐ തിങ്ക് ദാറ്റ്സ് ഓൾ. ഇതിന്റെ ടോണും നമ്മൾ കിട്ടും. ഫൈൻ. ഓക്കെ, ഫൈൻ. ഇത്രയും ഉള്ളു. പിന്നെ ഇത് എക്സ്പെരിമെന്റിനകത്ത് ടോണൊന്നും ജനറേറ്റ് ഒന്നും ചെയ്യില്ല. മിസ് പുറത്ത് അപ്പൊ അത്രയും ഉള്ളു. താങ്ക് യു ഓൾ ഫോർ കമ്മിങ് ടു മൈ ടെഡ് ടോക്ക്. I think ഞാനൊരു ക്യാമറ ഓൺ ചെയ്യാം. Okay, fine. I think that's about it. അപ്പം കൃഷ്ണ എല്ലാം ഓക്കെ അല്ലേ? Okay, fine. അപ്പം എല്ലാവരും thank you and bye bye.
Okay, thank you, Aanchal, for this wonderful session, and thank you all the participants for attending the session. So I think we can wrap up.